everyone. My name is Gijs De Boer. I'm a research scientist in the NOAA Physical Sciences Laboratory through work with the Cooperative Institute for Research in Environmental Sciences at the University of Colorado. I'm also the Associate Director of Science for the Integrated Remote and In-Situ Sensing Program at the University of Colorado. And I use drones in my research to make measurements of the atmosphere. The platforms that we use they range across a variety of different sizes, from very small, about 1 or 2 feet in length, to very large, where we're talking about 100 feet of drone. One of the aircraft that we currently use very frequently is called the Raven. This is a platform that was developed at the University of Colorado in conjunction with commercial partners. And this aircraft is approximately 2 meters across, so 6 feet or so, and has an endurance of about 2.5 hours. And we use this to make measurements of temperature, pressure, humidity, winds, turbulence, aerosol particles in the atmosphere, sky temperature and surface temperature, and a lot of other things. And it's been a very good platform for us. We've used smaller platforms as well. These are things that are about 2 to 3 feet across and are a little bit lighter and less expensive, and that allows us to put those aircraft into somewhat riskier situations, particularly places where there is more of a chance that the aircraft may not make it back because they're not quite as expensive, and if something were to happen, we wouldn't be as devastated. Of course, doing this safely to make sure that any aircraft that's lost is not going to endanger anyone or anything, but it allows us to make measurements in environments where we otherwise wouldn't want to put larger, more expensive platforms or platforms that had people flying them because of the potential risks involved with that. In addition, we've used what are called rotorcraft aircraft. These are copters, helicopters. There may be more the type of systems that people think of when they think about drones. These are very good for making measurements in a given environment where the aircraft needs to sit in one place. So for vertical profiling above a certain point, these platforms are very nice because they don't have to move forward to stay in the air. Or for taking samples at a given location while, for example, sea ice is changing underneath the platform. We've also used very large UAS or drones, specifically including the Global Hawk platform, which is operated by NASA. This platform is more of the scale of what you might think of as a small passenger jet and can stay in the air for really long time periods, over 24 hours at a time, to make measurements in faraway locations. It tends to fly at very high altitude and make measurements above the clouds, but it can also carry things like radars and other instruments that can detect clouds below the airplane. And those systems are used throughout the world to make measurements of the atmosphere, clouds, particles in the air, and the surface that lies beneath all of this. In particular, we're interested in temperature, pressure, humidity, how that varies in the lower atmosphere, how that helps with the development of clouds, and how it drives energy transfer between the air and the surface. We've been using drones for about a decade in our group, and broadly, the community has been working to leverage these platforms for almost 3 to 4 decades, since the 1980s. And things have come a long way. I think the last couple of decades, in particular, the last 10 years, have seen major advancements that result from all of the technology that we're developing, the miniaturization of a lot of different pieces and parts that are broadly used in things like cell phones, are also very useful for advancing our capabilities when it comes to aircraft platforms. And electric aircraft are very nice. They don't pollute as much as the fossil fuel combustion type of aircraft that were used previously. They don't interfere with our measurements. They're quieter, and they're much easier when it comes time to transport something to a remote location like the Arctic or the tropics. We don't have to deal with a lot of the potential pollution effects of carrying gasoline around and carrying a motor around that that has some kind of emissions with it. Along the way, we do make sure that we're following all the rules with respect to where we can and can't fly or how high we can fly. We have a very good relationship with the Federal Aviation Administration, working with them to produce what are called certificates of authorization that allow us to operate in certain areas. And with our group of pilots, we have a ton of experience trying to understand, how to best leverage these platforms and do so in a safe manner. So we do take a lot of care to make sure that we're doing things the right way and making sure that we're not invading privacy or things like that. We've had a lot of opportunities to visit a variety of places around the world and deploy our systems. This includes places like Barbados in the tropics, where we had some fantastic experiences with both local researchers as well as the international research community in making measurements of the air over the tropical Atlantic. And it also includes places like the Central Arctic. We just got back from a large project that occurred over the Central Arctic ice pack, where we deployed our systems from the ice alongside an icebreaker for approximately 6 months at a time and collected some really unique measurements over that environment of the lower atmosphere. So at the moment, we're deploying these platforms for a variety of different reasons and for a variety of different kind of scientific directions. I've been talking a lot about the Arctic, and there are some really big changes happening in the Arctic right now with respect to a warming climate and how that's impacting sea ice in particular. And so a few of the things that we can do with drones in that respect is understand the atmosphere over the sea ice. We can also make measurements of the sea ice itself. And one of the things that we did on our recent expedition to the Central Arctic is use one of our rotorcraft platforms to map out the sea ice surface on a regular basis and understand how the ice acts as it's melting. So how many ponds are formed on the ice, and when do those ponds drain, and how does that impact how much energy is reflected off of the surface in terms of sunlight. In different realms, we're also trying to understand a variety of unique and important questions. For example, we're getting ready now for a campaign that's going to be happening here in our backyard in Colorado, in the Crested Butte area. And there we're planning to deploy our drone systems to make measurements of, again, the surface in a mountainous valley region and better understand water and snow in that environment, super critical variables that are changing very rapidly in this unique landscape. And then in the tropics, we're making detailed measurements of the lower atmosphere to better understand the mechanisms that are driving cloud formation in that region. And the clouds in the tropics, in the tropical trades, are super important from a climate perspective because they dictate how much sun is reflected to space versus how much is absorbed into the ocean and how much goes into heating the ocean. We've seen a lot of different obstacles. Some of the things that we did anticipate are things like animals, which sometimes can be predictable. For example, when we operated in Alaska, we had to interact with a variety of different creatures, bears on the large end, foxes, a lot of birds, of course. Or when we were operating in Barbados, we ended up with a kind of unexpected animal issue where we were working to control a herd of goats around our operations area while we were trying to land an airplane. And so before we could land, we had to clear the runway of all the goats that were trying to figure out what we were up to. So it's always fun and exciting and brings a series of unique challenges. And we've been very fortunate to be able to push this operation forward and really move the needle in terms of the information that we can collect with these observational platforms.